This is the sixth and final section of chapter 9 on trigonometric graphs, and this section is about transforming trigonometric graphs. So the first thing I'm going to start off with is just a reminder of all the different types of transformations. So these are the transformations that we are going to apply to trig graphs. So some of them may require a little bit of rearranging beforehand so that we can easily see one of these types of transformations. Example 12, sketch on separate sets of axes the graphs of, and start with A, the graph of y equals 3 sine x. Now what I do on questions like this, I just start by calling f of x just a normal graph. So here it's going to be sine, and then I look to see, well, what am I doing to f of x, what am I doing to this? Well, I can see I'm timesing it by 3, so this gives me the transformation 3 f of x is equal to 3 sine x. So I know that this is going to be a graph that stretches by a factor of 3 in the y direction. So let's draw our axes like this, and we'll label it the x and the y axis. Now we're drawing the graph between 0 and 360. So let's do that. So we'll draw a graph that goes like this. Okay, so we'll mark down that this is 360 degrees. Should always mark down where it crosses the axis, 180 degrees, and then this is going to be at 0 degrees here. We also need to mark the peak and the trough down here. Now I can see actually from this transformation the normal graph of sine goes up to 1 and down to -1. If I'm stretching it by a factor of 3, this graph is going to go up to 3 and down to -3. So maybe I might draw that again because it's slightly too low. So let's try again. So up to there, through 180, down there, and then back up to 360. Okay, let's look at part B, and we've got the graph of y equals negative tan theta this time. So the first thing I'm going to do is I'll say let f of theta, since we're using theta, equals tan theta. Then I can see, because this is negative tan, this is going to be negative f of theta. So minus f of theta equals negative tan theta. So I can see that this is a transformation that's going to reflect the original graph of tan, reflect in the x-axis, So I'll draw our axis. So this time when we label the axis, we'll have one labeled as x, or theta this time, and the other labeled as y. Okay, I suppose we put a reflection in the x-axis, a reflection in the theta axis. Now I'm going from between negative 180 and 180. I'm going to draw the original graph of tan, and then I'm just going to use this to get my reflection. So once I've drawn my reflection, what I will do, I will sort of rub this out. So I've gone up to 180 that way. I need to go to negative 180 the other way. So let's put my asymptote in here, and then the last bit of the original graph is going to be like that. Okay, so reflecting it in the x-axis, when you reflect an asymptote in an axis, it actually doesn't move. So that will go down there, then reflect this up here like this, and then continue this reflection down here, and then reflect this over to here. I've made that look a little bit shorter. Let's try and make it the same size. So reflect that to there, and then I'll take out the original graph there, I don't need that anymore. And then my asymptotes, all I'm going to do is change those so they're now red. So asymptotes don't move when you reflect in the x-axis. Vertical asymptotes don't move. So there we go, like this. So last thing to do is just to label up the axes here. So 180, 90 here, 0, negative 90 here, and then negative 180. Example 13. Sketch on separate sets of axes the graphs of, and in part A, we have y equals negative 1 plus sine x. So we'll do what we've done before. We'll call f of x the normal graph of sine. So here I've got negative 1 plus sine x. Now another way of writing that would be sine x minus 1, wouldn't it? So sine x, I suppose it's written before so that you don't confuse it and think that the negative 1 is part of the sine x here. But that might help me with my f of x. So basically I've got the graph of f of x minus 1 or plus negative 1. So that equals negative 1 plus sine x. So I can see what this is going to do. This is going to move the graph up by negative 1 or move it down by 1. So I just need to shift the whole graph of sine down by 1. And we'll start by drawing an axis between 0 and 360. Okay, well, I've started off here just by drawing the normal graph of sine. And then what I'm going to do, I'm going to shift this all down by 1. So that basically means that where it's got 0, it actually is going to go down to negative 1, 0, or 1 here is going to go down to 0, and so on. And then this bottom bit down here, negative 1, should go down to negative 2. So I'm just going to make this axis a bit longer down here and probably mark on negative 2. And let's try and draw that sketch. So we're going to start here. I'm going to go up to there, down to negative 1, then down to negative 2, and then back up to negative 1. So I'll take that one off, like that. So this now would be our final sketch, and we just need to mark on the axis here, 360 here. The 180 is going to be sort of about here. And this point where it's touching the axis now, that is 90. And of course 0 here. Then we'll move on to part B, where we've got the graph of y equals half plus cos x. So again, if I say f of x equals cos x, then where I've got half cos x, that's going to equal, or half plus cos x, f of x plus a half. So what that means is the graph's going to move up by a half. So let's draw our axis, again between 0 and 360. So here's my graph of cos x. Let's move it all up by a half. So here we'll be going up to 1.5. Then where this goes down to negative 1, it's now just going to go down to negative a half. Like this, something like that. And then go back up to a half here. Not the greatest sketch in the world, but we'll take that out. And then we'll mark down that on the axis here, it's now gone up to 1.5. And the bottom, which was at negative 1, is now only at negative a half. And we'll just mark down here, this is 360 on our x-axis, the y-axis here. This bit here in the middle, that's going to be 180. And at this point, we don't need to work these values out. We could work them out because these are the values where half plus cos x equals 0. We could rearrange that and solve it to find out what these angles are here. Example 14. Sketch on separate sets of axes the graphs of part A. We have y equals tan theta plus 45. So again, let's call f of x, or f of theta, tan theta. So if we've got tan theta plus 45, that's the same as f of theta plus 45. Now this is a transformation that's going to move the graph this way by 45 degrees. Okay, so here's my normal graph of tan, and it needs to be shifted across this way by 45 degrees. So imagine the graph moving that way by 45 degrees. Another way of thinking of it is that the axis is going to move this way by 45 degrees. Now what I find actually easier to do, rather than shifting the graph, I shift the axis. So shifting the graph 45 degrees that way is equivalent to shifting the axis, the y-axis, that way by 45 degrees. So when I'm doing these questions, what I do is I draw the normal graph, like I've done here, then I find where 45 degrees is. 45 degrees is going to be, let's say, there, this point. And then what I do, rather than move the graph, I move the axis. So I move the axis to plus 45 degrees. So I'm going to take that out and move my axis to here. Right, now because I've moved my axis to this point, that means there's a bit of the graph I need to chop off because I'm going from 0 to 360. So I'm just going to redraw this and just take off that bit that I've chopped off. And because I've moved the axis by 45, I need another 45 at this end. So that bit that I chopped off, I basically add on to here. So let's just draw this so I can get that in. So this is where it ended before, and then add on, let's draw it neatly, let's add on 45 degrees. So I just need to stop basically where this one starts. So that bit that I chopped off there, I've basically added it onto the end. So I've moved the axis, the asymptotes don't move, so move the axis in the opposite direction that you're moving the graph, and then we'll label the axis here. So this bit here right at the end is 360. Right, now because the whole thing shifted by 45, the points where it crosses the axis in the asymptote's also going to move. Now we can work it out from this point here. So it's moved by 45, so if I take 45 away from 360, this point here is going to be 315 degrees. And then if I just keep on taking off 90s, I'll get these, because in the normal one it's like 0, 90, 180, 270, it's every 90 degrees. So if I've got 315 there, this asymptote is going to be 90 degrees before this. So I do 315 take away 90. That's going to give me this asymptote as 225 degrees. From this asymptote to this crossing point is 90 degrees, so I'll take 90 away from 225, and I end up with 135 degrees. Again, 90 degrees taken away from 135 will give me 45 degrees here. Okay, so this is the way that I tackle the questions, is that rather than try and move the graph, I move the axis. I draw the original graph, move the axis by this amount. Here it was plus 45 degrees. And then I've got a bit that's chopped off, I add it onto the end. Okay, part B, we've got y equals cos theta minus 90. So again, we'll call f of x, or f of theta, in this case we'll call f of theta cos theta. So what we've got here is f of theta minus 90, and that will be cos theta minus 90. So this is a translation, a movement this way by 90 degrees, but like the previous one, the way I'm going to tackle it is to move the axis in that direction, the y-axis, by 90 degrees that way. So I'm going to start by drawing a normal graph of cos. Okay, so I'm going to move this y-axis to negative 90. So negative 90 is going to be back here. So let's just draw where that graph is, negative 90. There, let's take that y-axis out. And now let's put the y-axis here, where negative 90 is. So that's now where our y-axis is. Now, since I've added on a bit there, I need to chop it off here. So this bit needs to be chopped off. So I'm literally going to have a graph that looks, well, it's going to be identical to sine. So I'm just going to take that out and draw it so you can see. So basically go down here, back up here. So that bit that was here before, like that, that's been chopped off because I've added an extra part at the beginning, and I only want to go from 0 to 360. So we'll now label up the axis now. So there's our y-axis, x-axis here. Then that's 360, 270, 180, 90, 0. So I'll just put down here this extra bit of information that the graph of y equals cos theta minus 90 is the same as sine theta. Example 15. Sketch on separate sets of axes these graphs. We've got 3 here to do. So y equals sine 2x. So f of x equals sine x. So this is the graph of f of 2x, because you can see that where there was an x, there's now a 2x. Now what this is going to do, this is going to squash the graph by a factor of 2 this way, or you can say that it stretches by a factor of a half, or 1 over 2. Yeah, it stretches by a factor of a half. I like to think of it as squashing by a factor of 2 in the x direction. Okay, now what I like to think of this like is like a spring. Think of the graph of sine x. So it goes up and down. It looks a bit like a spring, and that spring gets squashed by a factor of 2. You're going to have twice as many of these troughs and peaks in sine 2. And another way that I like to think of it is that this number here gives you the number of cycles between 0 to 360 degrees. Now what do I mean by a cycle? Well, that's one cycle. Yeah, so a cycle takes you back to like the start point again. So with a 2 here, I'm going to draw 2 of these cycles between 0 and 360. So I'll just squash it up a bit. So I'll go up, down, that's one cycle. Then the second one, up, down. There's my second cycle. So the graph has got squashed by a factor of 2, twice as many cycles between 0 and 360. Now because it's got squashed, these crossing points here and peaks are half of what they would normally be. So this peak here would normally be at 90, it's now squashed, it's now at 45. Where it crosses here would normally be at 180, it's now halved to become 90. This point here would normally be 360, that's now become 180. And so on, 270. And then we have the 360 at the end. And we'll just put the minimum and maximum here. So from -1 to +1. Okay, let's have a look at part B. And in part B, we've got y equals cos theta over 3. And we need to do this between -540 and +540. So we're just going to call this f of x, or f of theta in this question. Keep swapping between theta and x. F of theta equals cos theta. So then from there we're going to get f of theta over 3, or you could call it a third theta, couldn't you? Equals cos a third theta, which is the same as theta over 3. Now what will this do? Well, it will squash by a third, a factor of a third, but it might be easier to think of this as stretching by 3, which is going to be the reciprocal of a third. So it might be easier to think, right, we stretch by a factor of 3. Or another way of thinking of it is between 0 and 360, we're only going to get a third of a cycle of cos, only a third of a cycle. The previous one we got 2 cycles. Okay, now what I've drawn in here is the cycles of cos that I would get between 0 and 540 if I was to draw the graph of cos 540. Because it's only a third of this, so I need to take 1/3 of this to get to 1/3 to 540. So this is what I'd get with a normal graph up to 540. A third of this is going to be down to this point here. So I'm only going to get to this point here, and this will be 540, not where it would normally be over here. So let's sketch that out. So we've got this, and I'll label that as 540. And then we're going to have the same on the other side, because we're going to go to negative 540 over here. And we've gone up to 1, down to -1. And then we're just going to mark where it crosses the axis here. That'll be 270. So it's going to be like halfway between 0 and 540. And over here, this would be negative 270. Okay, moving on to the last one. So that's theta on the axis. And y here. Part C, what we have is y equals tan negative theta. So let's call f of x tan theta. So here we've got the graph of f of negative x equals tan of negative x. Okay, so what this will do to the graph, this will reflect it in the y-axis. We'll just write down here, reflect in y-axis. Okay, so here's my normal graph of tan. I'm just going to use that to help me reflect this in the y-axis. So then reflecting this goes like that. I'll do the same with the other parts of the graph. So just reflect them. So this gets reflected like that. You can see actually that the asymptotes don't change. And then the last bit, when we reflect this over here, we get that bit there. So let's rub out the original graph. We don't need that anymore. And what we'll do, we'll just change our asymptotes so they're in red instead. Like that. So we'll just label up the axis. So on this one we've got x and y, and we'll put in where the asymptotes are. So 90, 270, minus 90, minus 270. Now if you compare this to one of the previous questions, actually example 12 part B, you'll notice it's exactly the same. So the graph in that case was negative tan theta. Well, it's exactly the same as the graph of tan negative theta. So we'll just write that down. So there we go, just written here. So when we drew the graph of negative tan theta or negative tan x, it's the same as the graph of tan negative theta or tan negative x. So you should now be able to do exercise 9G on pages 197 to 198 of the textbook. Here's a recap and a couple of tips in terms of the transformations, in particular for trig graphs.